So this video will focus on 2.5. And so the very first thing it says, tell whether the ratios are or form a proportion. And there's a really easy way to do this. You could take a calculator, if you like, and go through and just divide the smaller number by the larger. So if I take like 2 divided by 5, I get 0.4. And if I then take 10 divided by 25, I also get 0.4. So they're proportional if when I divide whatever side I want, like the numerator by the denominator, that I'll get the same value on both of them, as long as I apply the same rule. So take a moment and do this for all of them. So for the next one, if I do 7 divided by 14, I get 0.5. And then if I do 21 divided by 28, I get 0.75. So this is not proportional. But again, it doesn't matter what I do. I can also divide the bottom by the top. So for this one, I'll take 21. So the bottom, denominator divided by 12. I get 1.75. And then I'll do the same thing with this one. I can take 30 divided by 15. And I get 2. So these are not the same either. So it doesn't matter what order you do as long as you apply the same rule. So let's go through and see, now that you've gone through and checked all these. This is yes, this is no, this is no. This one here is no, yes, and yes. And let's just double check this one here. So let's go back to this one. I could take 8 divided by 6. I get 1.33, whatever. And if I take 20 divided by 15, I get the same number. Or I can do the top, where I do 6 divided by 8 and get 0.75, and 15 divided by 20, and I get 0.75. So that's how you do those. The essential question is, how can you use these proportions to help you make decisions in art, design, magazine layout, and so on? If I look at this, it's asking if these are proportional. So I'm going to do the same thing I did before, where I take 5 divided by 6, and I get 8 or 0.8333. Again, I took the shorter side divided by the longer side. I'll do the same thing over here. 4 divided by 5, and I get 0.8. So this is not proportional. It will not work because it's not the same. If I look at this one here, and I do 6 divided by 8, I get 0.75. And if I take 3 divided by 4, I also get 0.75. And my sides that correspond here are the shorter side, corresponds to this shorter side. And the scale factor is 1/2. I could take 1/2 of 6 and get 3, and 1/2 of 8 and get 4. I now have to look and see if these are proportional. So let's look here, and if I take like this one here, and I'm going to take 8 divided by 7, and I get 1.142. Write this down because I'm going to forget it otherwise. So again, I'm going to get 1.1428. And now I'm going to do the same thing over here. And I'll take 7 divided by 6. I get 1.16. That's not quite the same, is it? And then I'll do this one here. And I'm going to do, so if I take that, that's 48 sevenths, right? 48 divided by 7 equals this, divided by 6. I get the 1.428, so I get the same as this. So these two correspond. So the original and design 2. Now what I did here, just so you know, is I took my 6 times 7 and got 42, plus 6 got 48. So I had my improper fraction, 48 over 7. I divided that number. If I do 48 divided by 7, I get this decimal. And I just divided that by 6 is how I was doing this. And that's how I got the number. The next one says whose dimensions are proportional. So I have a 5 by 4, an 8 by 6. Oh, draw 2 designs that are proportional. So let's just make it so it's going to be, instead of being 5 by 4, let's make it 10 by 8. Or I can do half of it, right? I can make it smaller. And maybe I'm going to do 2.5 by 2. And I can do that for all of these. So that's how you just make it proportional. You basically apply a scale factor. So in this case, I've applied both times 2. 5 times 2 is 10. 4 times 2 is 8. For this one, I applied a scale factor of 1/2. So 1/2 of 5 is 2.5, and 1/2 of 4 is 2. You can apply any scale factor you want as long as you are doing it to both of these. It will work. Are all three of these triangles proportional? Yeah, I mean, it has the same shape, different size, but they look the same angles. So, yep, it is. We're going to go through here and it says, are they similar? Remember, similar means that they might not be the exact same size, but they're the same shape. And I can look here and find out for corresponding sides. And if I look, 4 times 3 is 12. 4 times 3 is 12. 4 times 3 is 12. So the scale factor is 3. It will absolutely work. This one here, if I take 5 divided by 12, let's just do this real fast. I get this. And if I take 7 divided by 15, I get that. So again, 0.466 and divided by 12 was point. So this is not proportional because they're different numbers when I take the smaller divided by the larger. If I take 8 divided by 10, I get 0.8, and 12 divided by 15, I get 0.8. So these are proportional. They are similar. And then finally, the last one here is I can tell that this is proportional because 6 times 3 is 18, and 4 times 3 is 12. So it will absolutely work. So basically, they're similar figures. So if I look, I have similar angles. I have to look for corresponding sides and corresponding angles. So my corresponding sides would be like AC corresponds to DF. And it's really important that I say it in that order. If I said side length CA, I would then have to say FD because it's in the same position in which I start and finish. For the angles, if I look at angle B corresponds to angle E, you can see that there's like one little line here. For C, there's 2, and that corresponds to F for that angle, and D corresponds to A. So if I look here, which is similar to A, and I have 3 to 6, well, if I divide those, I get 1/2, right? This right here would be 1/3, and this would be 1/2. So A corresponds to C. For this one here, it says rectangle D is 3 units long and 1 unit wide. Which rectangle is similar to angle D? If I look back up here, that would be angle B, right? Because that would be it corresponds, like 2 divided by 6 is 1 and 3. So that would be that one. Example 2, find the triangles are similar, find x. So if I know that this is 6 and this is 8, it's getting bigger, right? So what I'm going to do is take my calculator and I'm going to find the scale factor. Since it's getting bigger, it will be 9/6. So I'll do that, 9 divided by 6, because that will be a number greater than 1. If I did 8 divided by, or 6 divided by 9, that'd be a number smaller than 1, so therefore it'd get smaller, which wouldn't make any sense here. If I multiplied 8 times this, it would be smaller, which does not make sense. So that's why it's going to be 9 divided by 6. So I'll do that again, 9 divided by 6, and I get 1.5, and then I'm going to multiply that by 8, so times 8, and that means that this side length should be 12. This one here, I'm going to look at my corresponding sides. I'm going to try to find the x is a smaller side length, so I have to find a scale factor that is smaller than 1. So that would be corresponding sides 6 and 9. So I'll take 6 divided by 9. That should be a number smaller, which it is, and multiply that by 6. And that means that x equals 4. For this example here, it says the shorter base of the similar trapezoid is 3.75 inches. What is the height? So that would be right here. Again, I'm solving for the smaller one. So my scale factor, my corresponding sides would be 3.75 and 15. So I'm going to take the smaller, 3.75, divided by 15, because I want the number to be smaller than 1. And I'm going to say times 12. And I get 3 for my h. It says, what if a longer base replica is 4.5 inches? What would be the length? So we're going to do the same thing, only it's going to be 4.5. So I'm going to do 15. I'm sorry, I want to make it smaller. So 4.5 divided by 15 times 3. That would be, let's try it one more time. I don't know if that's right. So 4.5 divided by 15 equals 0.3, and then times 12. 3.6. That makes more sense. And that is essentially the lesson.